Okay, so I'm your presenter today, Ed Kitlinski, Zen Solutions Consultant, and I wanted to go over this agenda really quick and these slides. I do have a few slides that really go into some very good detail about benchmarks that we've done not too long ago with Acquia about, with Zen Server together with Drupal, and I'm going to go into those details, as well as hopefully if I have some time at the end, I'm going to show you an actual example and demo. So the agenda today really will go into details about Zen Server. We'll go into a lot of details about the benchmark that we ran against Drupal with Zen Server. We'll talk about all the kind of capabilities that includes caching, bytecode caching, full page caching, things like that. We'll look at the benchmark results in a lot of detail. And then what I'll do towards the end, as I said, if I have just a little bit of time, is I'll actually implement one of the rules that we had shown with Zen Server. So that'll give you kind of a flavor of how this is done. So just a quick introduction. Zen Server is a complete enterprise-ready web app server for running and managing PHP applications like open source Drupal that require a high level of reliability, performance, and security. So I'll be using Zen Server today. As we go through the benchmarks, we used it as well as in the demo that I do later today. Zen Server is a complete, well-tested PHP stack that's easy to install. It's usually under 5 minutes and easy to keep up to date with online software, security, updates via repository, as well as tight integration to Zen Studio so that you can quickly and easily customize Drupal sites. There are two versions available, a free community edition and then an enterprise professional version of Zen Server. The full version is what I am demoing, as well as what we've done the benchmarks with. That's a fully supported by the Zen tech support staff. It also offers a superset of capabilities from the Community Edition, and I'll be using a lot of the kind of additional capabilities that are not available in Community Edition today to kind of supercharge Drupal. So we'll talk about that in detail. The full professional edition was used, again, in these benchmarks today. The other features we won't have time to talk about on Zen Server, but they include things like Java integration if you ever have to do that with PHP. There's a job queue that allows you to parallelize PHP tasks. Again, we're not going to talk about that, but that's another huge area that can definitely affect performance. If you identify areas within your site that can take advantage of that, and then there are other kind of capabilities like the cluster manager, which is fairly new. I'll talk about that briefly, but again, we've got a lot of webinars up on the Zen.com site. I definitely welcome you if you're interested in any of these other kind of capabilities. Don't hesitate to jump on the site. We do have presentations that just focus on those specific things. So just a quick introduction as to what's new in Zen Server. So I wanted to talk about that just really quickly, especially one that we've discussed later in this presentation, something new called code tracing. It's been updated and included in Zen Server, and definitely becomes very, very useful when you're diagnosing performance bottlenecks in Drupal. So it's a big area that we constantly use in our professional services organization here at Zen to identify where are there performance issues, especially in the code, even when they're really difficult. But we'll definitely take a look at that in my demo. And that is a big part of the troubleshooting that we have built into Zen Server. Code tracing, just as a background, code tracing acts like an airplane black box, capturing complete application traces for problems to help you as a developer diagnose the issues quickly. We'll go into more details, again, about this specifically to Drupal. I'm sure once you take a look at how you can take advantage of code tracing, you'll be excited about the possibilities and opportunities to use it, especially in production environments. That's really where it shines. It was specifically built to help the staff deal with performance issues in production. So Zen Server also supports PHP 5.3, 5.2, so both versions are supported and made available under Zen Server. For larger Drupal sites that span multiple servers, Zen introduced something new called Zen Cluster Manager. Again, I'm not going to go into too much detail about it. It again will help when you've maxed out a single server with your Drupal site and need to go to multiple servers. Again, the Cluster Manager helps you scale to multiple servers. It helps you identify problems in one place, alert the staff if there's a problem so you can be proactive. Again, a lot of detail about that in a separate webinar, but I did want to just quickly mention it today. And that is available as part of Zen Server 5. And if you're thinking about deploying Drupal into the cloud, Zen Cluster Manager also makes it really, really easy in a utility computing model to scale up and scale down very, very easily. So that's something we went into a lot of detail on in ZenCon, and again, webinars on our website if you're interested. So finally, something new is the job queue capability. I talked about it really briefly. It does allow you to parallelize tasks within your PHP app. Again, Drupal is an example where you might have areas within your Drupal website that can be parallelized. The PHP task can be parallelized and shortened. Again, it is another area to optimize, but again, it's very specific to the performance bottleneck that you're having. But I did want to bring it up, and we do have presentations about job queuing. So again, I won't have time to talk about that in too much detail today, but I do want you to be aware of it and take a look at that on our website. So let's kind of jump into the areas that I will have a lot of detail about on today, as well as time to talk about, and that has to do with benchmarking within the Zen Server and Drupal sites. So Zen Server provides multiple capabilities for improving application response times and minimizing resource utilization. So in the benchmark today, we'll review how opcode caching can help improve PHP script performance, how data caching API can further improve performance, and then we'll be using page caching, which allows for even better gains in performance. Once you identify the bottlenecks. So we'll look at all these areas, and again, Drupal does provide for its own caching internally, which we've used. So I'll talk about that. Just as an overview about our benchmark environment, it's always good to know how the benchmark was done. This is kind of the environment we used. In this Drupal benchmark, we kind of compared several common PHP runtime environments and configs. So the application used for benchmarking was Drupal 6.15, running on plain PHP 5.2. And we also tested on Zen Server with the same PHP versions and open source. So we basically used open source PHP 5.2 and then the Zen Server version of PHP 5.2, compared them back to back, and we used several optimizers, open source optimizers such as APC. The version we used was, excuse me, APC 3.1.3P1 and WinCache on the Windows environment. So we ran both Linux and Windows benchmarks. So we did use open source caching for comparisons against Zen Server's built-in caching. And then for purposes of the benchmark, a simple Drupal-based website was set up and tested in various commonly used Windows and Linux configurations. A pair of stress test servers that you see here on the right-hand side were used to basically simulate user stress. We basically simulated using the web capacity analysis tool, simulating about 50 concurrent users connecting for about 3 minutes. So that's kind of a little bit of a background. Scripts and what we did, basically we automated scripts to go against some of these pages, which included the home page, the blog, some of the nodes, as well as the forum, some comments, things like that. So we automated a script to basically go against a website. The pages on these nodes for comments in the forum were about 1 to 1.5 kilobytes in size. So again, most sites are probably much bigger than that. So Again, your tests will vary, but probably the performance will get even bigger with more content down there. For sure, they'll get bigger because caching makes a much bigger impact the slower the site gets. But that's how we calculated the benchmark. And again, we use WCAT to run the test scripts to collect the benchmark equipment and then results. So Drupal supports multiple caching schemes as well. So both external caching, like I should say internal caching that it supports, called built-in page caching, block caching, as well as something called Boost, as well as external type of caching. That would include PHP language bytecode caching, which we did utilize, database caching, VMM cache, or other kind of capabilities, something like the caching API, which I'll talk about, also plays here, as well as page caching. And page caching can be achieved by a number of things like proxy servers, but Zen Server actually has a much more sophisticated way of caching full pages, which I'll talk about and probably demo. That's what I'm hoping to do. Okay, so the first benchmark test basically tested bytecode caching in all the PHP stacks. So as an introduction to what bytecode caching does, let's kind of review a typical running PHP script. Is parsed, it's turned into bytecode, then executed by the Zen engine. This happens for every request on the website. So what a bytecode cache will do is to skip the parse. I should say go through the parse step one time, the first time, turn it into bytecode, store it into memory, and then any subsequent request we would be executing from the memory bytecode version of that page. So Zen Optimizer Plus improves PHP performance typically 2 to 3 times faster when you compare it to open source PHP. By doing this, this obviously eliminates the stages of parsing from the disk and compiling it on every request in Drupal. For further performance improvements, the stored bytecode is optimized for faster execution. So this component works out of the box and doesn't require any changes to your Drupal code at all, or any PHP application that you're running. And in this benchmark and others, you'll see that Zen Server Optimizer Plus caching is both faster than APC and WinCache bytecode caching. That's the two that we basically compare to. So in the benchmark here, you can see we compare just we try to make this apples to apples, just bytecode caching, no other type of caching, just to make it an even comparison. So the results basically show that using PHP 5.2, normal caching enabled Zen Server was almost 3 times faster than just open source PHP alone. When we compared Optimizer Plus, which is the bytecode cacher that's built into Zen Server, when we compared it to APC bytecode caching, we're about 20% faster, 19% faster, so we were in that ballpark. And then when we compared this on Windows environment to WinCache, we were somewhere in the neighborhood of 24% faster. Again, these benchmarks are available on our website if you're interested to dive in a little more deeply than this presentation is talking about. Okay, so the second area that we kind of focused was really in the shared memory, or what's called disk data caching. Provides you both options to determine where to store your cached variables, database results, or parts of a rendered page. So this is an API that we're using. Memory caching provides server responsiveness and increases performance, primarily in environments that run high-traffic applications that can benefit from offloading activity directly towards the hard disk or shared memory. So disk caching is more suitable for smaller applications and ensures that cached content is available after the machine is restarted, and also allows you to save valuable memory for more important reasons in your app. So in this benchmark, we had to modify the Drupal code to utilize this. Again, this is an API that can be applied to code in certain sections to cache that code both into memory and to disk. And in this benchmark, we basically cached certain modules like blog, the forum, comments to take advantage of shared memory storage using the Zen Server API as well as the other APIs that are available in APC as part of this. What it looks like is basically, this is a sample of the code, and if you look at here, here's a function that gets recent posts, and what you see right under the function call is a call that goes to Zen shared cache fetch with a key, so it looks up to see if the data's already been cached, and then there's an if statement, which if it has been cached, it'll skip the rest of the function call. If it hasn't, it'll execute and then cache the rest of the call. So it's fairly easy. In APC, it works the same way. And I also wanted to mention that Zen Server, while we're talking about APC caching, data caching, if there are applications that you've already written using the APC API, its developer API, Zen Server is compatible to it. So it basically maps on top of it, but utilizes its own performance enhanced caching. So no need to reprogram your code. It'll think that APC is installed, but it's actually Zen Server with a APC compatibility layer kind of using its own caching. And the results, when we look at it, basically come down to this. So we compared, again, the Zen Server memory caching versus APC and saw 21% better performance versus it. Again, it was more than 4 times faster than using just plain open source PHP, which wasn't using any caching, so it just as a comparison, and was about 12% faster than Zen Server using just bytecode caching alone. So we kind of compared those result sets to give you an idea. Okay, and as I said, I mentioned earlier, the Zen Server does provide for a compatibility layer. It uses its built-in more optimized caching, even if you've written code that uses the APC API. Okay, so let's move on to another section that we tested, which was full page caching, and this is for the next performance test, we reverted back to an unaltered Drupal code. So we didn't make any changes. All those changes from the earlier version we wiped away. This is unaltered Drupal straight off the website, and what we did is we used full page caching. So this is a capability that doesn't exist in open source, where you can cache, I should say doesn't exist in things like APC and things like that, which you can cache entire pages. And this makes significant bigger performance improvements. It actually bypasses the PHP engine once things are cached. Zen Server was the only one of the stacks that supported this type of optimization called full page caching. This option is used to cache the entire page output of a PHP script without changing any of the PHP code in Drupal or any open source or custom code that you've written. So again, it doesn't require changes to code to kind of activate this. You'll see in a minute how this works. It basically caches HTTP responses. So it matches what the HTTP request is, looks up in the rule set to see if this is something you want to cache, and then if it's available in a cache, it'll retrieve it from cached version, so a static version of the page, basically. If it's not available, it'll render the page and then make a backup copy of it in the cached version. So it does this automatically, and again, without requiring any changes to the open source code or your own custom application. Okay, so let's look at a quick example. We're using, just really quick, the version of Drupal we were using for this benchmark was the press flow version of Drupal. The reason we did this is the press flow version includes some optimizations, so cookie hints basically, to help in optimizing Drupal websites. So that's the reason we were using it for this particular part of the testing. If you're not familiar with press flow version of Drupal, it's an optimized thread of Drupal. Just do a quick search. I think it's under pressflow.org if I'm not mistaken. But it's up there on Google. Anyway, the rule looks something like this. This is a form. We're inside the GUI, the Zen Server GUI. And what we've done is we've created a simple URL rule. This is I'll create one of these in my demo today to give you kind of an example of how this works. So to measure the impact of full page caching, a scenario was created that caches non-authenticated access to Drupal. So people that are anonymous were being cached, while people that are logged in were just executing the code itself. So that was the scenario that was used in this rule. Okay. And users and login pages were also excluded from caching. So this URL matching rule, if you take a look at it, it's pretty simple. We give it a name, a rule name. Then step one there under caching conditions, we basically created a set of rules that said, match this using regular expressions, any request to this website, that's what that .star is after the HTTP, or we could put a domain name there, a specific domain name, but we kind of wildcarded it because there's multiple web servers in this case. And then the second one there basically is what application. So this is Drupal, and again, .star we wildcarded with a regular expression to say any request to Drupal except, this rule should accept. And we've added just a few other additional things to the rule. Get request, if there's a get request to queue, the regular expression doesn't match, so it's any request that's basically starts with the user. Again, .star, so we wildcarded it. Another get request to queue if it doesn't equal logout. So again, we don't want to cache the logout page or user pages. We want those to render every single time. But we do want to cache, and that's what this last part of the rule says, is sessions. If the session user ID, that's the session variable, is UID, does not exist, basically the users are anonymous, so they haven't logged in. If the user has logged in, the UID would actually, that session variable would be set. So that's the general rule. Again, this is done via again, it's a very powerful rule, much more powerful than proxies, because we're doing introspection not only on things like cookies, which we're not doing here, but we can. Cookies are one of the variables, but we're taking a look at get variables, session variables, and determining whether a full page should be static or non-static. Okay, that's what we're doing here on the page. Okay, and then if you look under step 2, very simple. We're just caching this for 30 seconds, so it's time-based. So after 30 seconds, the page will render again for a user that clicks on it, the home page or any page, because it's any page accepted under Drupal except for the logout or user pages. So it'll render again and then create another static version. So that happens every 30 seconds. Okay. All right, and the last thing on here that says server query string basically says that if there's any change to the URL, we're going to create a different static copy of it. Zen server will create a different static copy. So different nodes, when the get variable queue changes and you're on different pages within Drupal, it's a different request, and basically we'll have a different copy of the page saved on Zen server. And that's all that the last part of this rule is basically saying in step 2. Okay, so very simple. And we'll show a quick demo of that in a second. So let's get to the results. So we get a nice bump in speed here with Zen server full page caching about 85% faster than the fastest benchmarks from the APC shared memory numbers, and about 683% faster than just open source PHP alone. So if you compare that to just using Zen server with the optimizer, the language optimizer, we've got a speed boost of about 75% faster than that. So giving you kind of an overview of the type of performance boost that a full page caching can provide. So, the earlier rule, I should have made this clear, I'm sorry. The earlier rule was on plain vanilla Drupal. This is on the press flow version, which does have cookies. So here we're using a cookie hint. Okay, so again, we redid the rule. We're doing, again, we created a rule called press flow. The cache rule says matches regular expression. Again, we can have a domain name, HTTP, and after that, localhost or domain name / any request. And before it was to Drupal, this time it's to PressFlow .star, so we'll accept any request to the application. And the only thing we have here is if cookie exists in the cache. If it doesn't exist, we don't want to cache it. If it does exist, then we'll cache it. And then here we cache it for about 300 seconds. And again, the final part of this rule says if there's any changes to the query string, again, the get parameters change or anything changes on the query string, we're going to create a separate copy stored locally within Zen server to be retrieved later. Okay, so with this scenario, PressFlow. What did I want to say about this? So the API for Drupal that includes performance was backported from Drupal 7 into PressFlow. One of the features that was added was, again, this cookie variable that can be used to determine whether a current page is being rendered or for authentication, if there's authentication happening or not. This, again, allows for faster full-page caching, completely eliminates any overhead associated with introspection of sessions and things like that, which is, again, not even possible with things like proxies, but is totally possible with Zen Server. So that kind of gives you a good idea of what some of the benefits, plus it's built into the same web tier. So just as a benchmark, as a watermark, we measure the PressFlow version against the Drupal, and it was about 36% faster than standard Drupal with no other tuning other than these rules. And again, the Drupal caching was enabled. The internal Drupal caching was enabled while we were running all of these full-page tests. Then we enabled Zen Server page caching using this cookie rule that you saw, and we got basically a 2,605% improvement versus just standard open source PHP, which doesn't use any caching except for Drupal, the built-in Drupal one, and about 734% faster performance than the fastest APC numbers. So effectively using full page caching based on cookie results in performance equivalent to that of static HTML. It bypasses and does that by bypassing the PHP engine at all. It does that by using the full page caching part of Zen Server. So that's about a 26 times faster than plain PHP, open source PHP. While full page caching cannot always be applied, using it where possible can make a remarkable difference in performance. The good part here is you can mix and match. You can use full page caching in parts of your application. If there are other pages that require the data to be very, very interactive, very dynamic on part of the page, and other parts of the page can be static, you can use the API set for those pages. So you can definitely do mix and match on that sort of stuff. So in all the prior benchmarks, we were working on a standard unaltered build of Drupal or the PressFlow modded branch of it. But we all know that most Drupal sites are far more customized than a standard version that's downloaded. What makes Drupal so great is, that you can customize it and add things, add your ideas to it. But many times the performance bottlenecks are not in the core Drupal code, but are basically in these altered modules. Whether they're alterations that have been made by by you or your staff, or just mods that you've downloaded. Again, they can severely affect the performance of Drupal, and again, in most open source applications, kind of face these kinds of performance bottlenecks. So, how do we find these performance bottlenecks when they're introduced into the core code, like Drupal, and look to fix them fast? So, Zen Server provides both monitoring and deep code trace visibility into where bottlenecks are. So this is a very big part, a very important part of Zen Server, allowing you to drill in and identify where there are problems, performance problems and drill into the code, even if they're difficult ones. I mean, a lot of times performance problems happen in production environments. They're hard to reproduce. They're seemingly random in nature because they're not consistently happening. It's really the production environment that you really face the most challenging types of performance issues. But Zen Server actually has both monitoring and code trace capturing, even in a production environment where we capture exactly where in the code we're seeing these performance bottlenecks. Even if a user is typing something into a form, sometimes it's something as simple as a form that generates a certain type of SQL that creates a very poorly executing SQL statement, and it doesn't always happen the same way when you're testing and things like that. But Zen Server will capture those kinds of environments. It does that via events like this. You're seeing a screenshot of Zen Server monitoring. So Zen Server installs a monitoring extension to identify problems deep inside the runtime of PHP engines. So problems such as PHP errors, failing functions, bad database queries, slow functions, things like queries, slow queries and functions, slow scripts, memory issues, things like that. There's I'd say about 18 different categories that we're monitoring. We're doing this deep from the PHP Zen engine level. There's no need to make any changes into the API. We're basically covering the entire application, every single line of code. So even scenarios that the developer never anticipated would be a problem, a memory problem or a performance problem, we're going to be capturing and monitoring that. So that's really, really important for you to know that Zen Server monitors from deep within the Zen engine level and saves a lot more detail than typically a developer saves in his log file, his error log file. So in this screenshot, we basically drilled into a performance bottleneck identified by Zen Server. We can see here there's more details are provided to us how often this problem is happening in our server. In this case, the problem happened about 32 times in the past 2 weeks, and we can see a trend window on this page. And basically, this page is rendering about 3.5 seconds, so definitely slower than I've got a threshold here that says any page running slower than 2 seconds is considered a bottleneck. So that's how we're identifying what's slow. The default rule here is capturing the performance issue. It's capturing a lot more detail. So what the get parameters were, if there was a form, we would have captured all the form information. That was part of this request. Again, the timing was captured. And a button on top that you should see is called Show Code Trace. So we can dive deeper into the code, not just what the request was, but now where in the code and what was the timing, exactly where where in our code was the problem happening. And that's really what the show Code Trace allows me to do here. When I click that Show Code Trace, what I see is basically a window pop-up. That's the small window here on the right-hand side. That either can be imported into Zen Studio. Zen Studio has an import of this, so production problem, you can export this type of event and then send it to the developers, or you can use the web interface. There is a web interface to this as well. If you've been given the rights, you can bring up this web interface that basically traces through the code. And I'll go through this during my demo. But the key thing that I want you to realize is that there are scenarios, again, in production that we cannot reproduce. We can't use a debugger. We can't use a profiler because it'll update the database. So it'll make changes to the production environment. So those tools become useless. Code tracing has happened during the actual problem. We at Zen like to call this kind of our black box, a lot like an airplane black box that's constantly monitoring and capturing when a problem happens, is capturing all the details in the system about your problem. That's really what Code Trace is doing here. And it's doing this during the problem. So when a problem is triggered, like I said earlier, I had a 2-second threshold for performance problems. So anything over 2 seconds triggers a capture of an event, and in addition, I told the Zen server environment to also capture exactly where in the code. And that's where this comes up, and it allows me to then dive deep. On the right-hand side, it tells me what functions were called. The middle two columns show me how much time it's taken to execute that function, and then to the right-hand side, exactly what include file am I in and what line number am I in. So it acts very much like a debugger and profiler, but in history. So this is things that have already happened in real time. I can just go back and kind of diagnose what the problems were. We can also see what parameters were sent in, what results were sent back from a function call within Drupal and things like that. So there's a lot of detail here, obviously, to diagnose a performance problem. And again, this is a close-up of what it looks like, but I'm going to demo this in a second. So while I wrap up, I just want to let you know we do have a lot of information about CodeTrace. I'll do it really quick in my demo, but feel free. There's a really good webinar online, and let me now share my browser and kind of go through the demo really quick. Okay, so everyone should see Zen Server up and running. Again, this is the full professional version of Zen Server. You can tell the difference between CE and the professional version. One, these events show up, and you have an event tag that has all the events that are happening in our environment, as well as most of these extensions to Zen Server are turned on. I purposely turned off a few of these, but when you install Zen Server for the first time, all of these on the right-hand side should be turned on in green. Okay, that's one of the ways of actually telling whether you have the CE or PE version, professional version. And if you have the CE version, you easily can upgrade. Just download the full version. It'll install on top of the CE version with all the additional capabilities. When the license expires, the trial license expires, it just reverts back to CE. So there's no downside in trying the professional version. If you folks are interested, I definitely recommend just downloading the full version. So what I have here is I have a Drupal application. I have a few reports. The only thing I've modified is I've added some reports to my Drupal environment. So this is standard Drupal. I've added these reports, and they're basically rendering really, really slowly. So it's taking more than 2 seconds. DB sample is a database report. It's just taking forever to render those pages. If I redraw the Zen Server front screen, you notice that there are new events that have just been captured. Okay, and for example, we've got severely slow execution of certain pages. So these are performance bottlenecks. The way Zen Server captures this is under rule management. We've got a number of these are built-in rules that are monitoring for performance. Remember I said 18 different categories, so things like functional errors, database errors. So in other words, this default rule says if any of these database functions return a false, we're going to capture that as an event, okay, and the detail about that event, because again, function calls, database calls should not return false, otherwise there's some sort of problem. Same thing with performance problems. So we have a few default rules here that say if functions are running slower than 2,000 milliseconds or 2 seconds, it's a slow running function, so capture that as a performance bottleneck. The one that I just saw was this one. It's a severe slow request execution. Again, any script that runs slower than 2,000 milliseconds or 2 seconds, it's capturing the detail. It's considered a bottleneck in my system. That's a default number. You can obviously adjust this number, but 2,000, the default seems to be pretty good for most websites. The second part here I've modified. So this, aside from the second step, this is all out of the box. What I've done is I've turned Save Code Tracing on. So the next level of detail, basically, not only do I want to know that this request is slow, but I want to know where in my code is the code slow. Okay, and that's what Save Code Tracing is all about. Normally, out of the box, this is turned off. I recommend downloading Zen Server and trying Zen Server. Turn this on. The send email, if you want to alert someone that there's a particular problem, you can send a proactive email also via Zen server. So I did that here on my Zen server. I'm sending myself messages when problems occur. So let me go back to the front page. And again, the second problem, I'm going to drill into the second one. And here, what you should see is a lot more detail about the request that was having a performance problem. To the left-hand side, I have a trend of how often this problem has occurred. So if you take a look at here, basically the last time it took a little bit more than 4 seconds. But I've got a trend. Notice also that when the same kind of problem happens in the same place in Zen server, we're not appending to a log file. We're consolidating this all into one event. So you notice we're counting that this performance problem happened 58 times inside of Drupal. We have a trend of how often it's happened. Again, we're counting every day how often it's happened. Allows you as a manager and you as a developer to prioritize where you spend your time if a problem obviously is happening in production more often than other problems. It's probably a better idea to fix the most common problems first. And this will help you identify those really, really easily. The request here, a lot of information is being saved, a lot more than typically we as developers save. Again, this doesn't require any changes to the code. This is all happening from the engine level. It's happening on any line within the Drupal source code or any open source code. It doesn't have to be Drupal, but we're using Drupal today. But it's going to capture all of the get parameters that were part of the request. If the user typed something into a form that caused a performance issue, all the post information would have been captured here. All the cookie info, server-side info was all captured. And if we're in development, we could debug and profile this. That's what the 2 buttons on the bottom are. But in a production environment, again, it's dangerous. Maybe we're updating something in a database. Maybe we're changing something in a production environment if we reproduce this problem. So in this case, what we have new is something called code trace. And this is what I talked about earlier. This is the black box. This is the web interface to it. If I wanted to, I could also import this into Zen Studio. And all I did is I clicked highlight most time-consuming path, and it'll go through the first page of my request and highlight exactly where the performance problem in the code is. I can also look at memory issues by clicking the show memory. So if it's a memory-related problem, if I'm running out of memory or getting some sort of odd issue with my system, I could take a look at memory issues as well and find out where in my code the memory is being used up. If you look at the chart here, it's really easy. Left-hand side are the functions or method calls. The middle is a bar chart in blue and gray. Blue is saying that this is the longest running part of the code. Next 2 columns are how much time in percentage. So this part of the code is, for example, taking 70% of the total transaction time for the entire request, and then how many milliseconds? 3 seconds, for example. And then the last column, what include file is this code in, and then what line number are we executing? Okay, so again, very much the same type of information that a debugger or profile or a combination profiler would give you, but in real time. This was captured during the actual problem in production. And that's where the power is. And so if I go deep into the code, I can basically keep drilling in and finding exactly where my performance issue is. So I'm drilling into Drupal. Again, there's no extra logging that I've added. This is all happening from Zen server just by executing the PHP code. And any open source, not just Drupal, any open source application or any custom PHP application can take advantage of this type of monitoring and deep analysis. And as you can see, I've kind of drilled to the end. It basically stops here. The long blue lines end right here. It's telling me that something was included in my Drupal report. It was evaluated. It even tells me what was evaluated. If I go back a little, it's telling me what's being evaluated, and that took more than 70% of the time was evaluating this PHP code. So if you guys are familiar, you can evaluate PHP code as comments or articles, okay, and that's what's happening here. There's some poor running code. And it's telling me what that code is as content that's being evaluated. And eval, frankly, is a very poor performing function anyway in Zen Server. So one of the things I can do here is cache. Remember we talked about earlier, caching is a big part of the benchmarks and really where we take advantage of it. So let's do that. I'm going to, instead of using the API, I'm going to use a full page rule, create a really quick rule. We can call this fast Drupal. And this is, again, our full page form where we can match the URL request and basically cache requests. And that's what I'm doing here. I'm creating a rule that says any regular expression match to localhost or domain name. I could put a domain name, and any request to Drupal. And what I'm going to say is I'm going to wildcard it with a regular expression. Dot star means any request to the Drupal application. I can add basically I can add other things here to say if the get doesn't match log out. So I don't want it to cache when we're logging out. If the session variable is user ID, UID, doesn't exist, so meaning the user hasn't logged in, I want you to cache. And so I've created a really quick rule based on some parameters, some get parameters, some session parameters to decide whether I should cache the request or not cache the request. And that's really what that's allowing me to do. And finally, what I'm going to do on the bottom in step 2, the last step, is basically add entire query string. So here I basically say if the request, if there are any changes to the get parameters or any changes to the query string, cache different versions of the page. And then I could basically put how long to cache it. It is time-based. I'm going to save this rule. I'm going to restart PHP. Restarting PHP here does a graceful restart of the Apache server, and this will activate the rule. Oh, sorry. Let me delete that rule. I already had a rule like that. So let me restart that. Didn't notice that. Okay, so we restarted it. And then if I go back to Drupal and I go back to the reports, the first time I click on the report, still has to go to the database, still has to generate the report. It still will take 3-4 seconds to generate the report, but there's a backup copy of it, so there's a cached version of it now. Same thing with the top 10. Still has to go to the database, still has to create it, as well as the DB sample. But now when I go back to the reports, they'll retrieve from cache and be instantly available. So sub-second response rates because we're retrieving this from cache. So that's a really quick example of how you can use Zen Server both to identify where the bottlenecks are in Drupal. 1, that's a big area that Zen Server helps you with, and then 2, gives you tools to address certain bottlenecks, whether it's full page caching like I was using here for reports, because these reports don't change more than hourly. For example, this DB doesn't change more than hourly, so I can have this cached every hour. The year to date changes quarterly, so I can cache that much longer. Top 10 doesn't change except for quarterly. Again, so there's a number of rules that I can apply to any of these to further optimize and cache them according to their data result sets. But I wanted to keep this simple just for illustration. Anyway, that pretty much ends my demo. There's a lot more here to Zen Server. I'm going to try to go back to my application and take Q&A. Share document. Okay, hopefully, yeah. Okay, so that basically ends my demo. I just want to let you folks know there is a detailed Drupal white paper. It is available on our website. There's the URL right there available for you. Another good way to get to it is just to go on the solutions section of Zen.com and look under the Drupal part of the solutions section, and that's where you'll find the white paper and a lot of information. Okay, a lot of other great webinars available to take a look at different parts of Zen Server, as well as this webinar. This webinar in a few days, Lydia basically said that she'll also put this up, so just wanted to let everyone know. If there's any questions, I'll take those right now. Feel free in the chat or QA section to write down your questions, and I'll try to address those in the remainder of the time that we have. Okay, one question had to do with Zen Server. Is it available on Windows? Yeah, it is available on Windows. We did run these benchmarks both on Windows as well as Linux, and the same capabilities on both. I think the only additional capabilities that Windows will have is support for Microsoft SQL Server, or I should say better support for Microsoft SQL Server, as well as IIS, web server. So we support both Apache and IIS on Windows, as well as the Microsoft SQL Server drivers. So those are much better on the Windows version. So that's kind of the only other difference between the two. But otherwise, they both function the same. And the demo that you just looked at, I was actually running on Windows. So just to give you a heads up. But yes, both versions are available. And we support, for the Linux folks out there, we support all modern versions of Linux. So I'd say about 90% of the distributions out there, things like Red Hat, Fedora, Ubuntu, Debian, all of those kinds of things are supported. Mac version, yes. Mac version, unfortunately, we only have the Community Edition for today. So we don't have Zen Server, the full version on the Mac. I do have a lot of developers, Mac developers, basically use a virtualized environment, like a Parallels environment, running Linux or Windows in the background. So you can do, you can use Zen Studio in Mac and then communicate to a virtualized version of Zen Server. So for now, that's for the full version of Zen Server on a Mac. That's probably the recommended way. Okay. Web server Nginx. We don't support that right now. Really, it's what we support today is Apache as well as IIS for Windows. So both on Windows, on Linux, it's Apache. The architecture, I didn't talk about that much, but Zen Server's architecture is very much the same as open source PHP, except we've extended all the additional capabilities or extensions within PHP. So again, we install just like open source PHP as an Apache mod in Apache and a CGI inside of IIS. So that's kind of the typical ways of installing open source PHP, and that's really the same way that Zen Server is installed. The big difference between installation is on Linux, Zen Server supports repositories. So what you'll find as a Linux user, if you're using RPM packages or on a Debian environment, the Deb packages, you can use yum or apt basically to install Zen Server. So very easy to install it. Also very easy to upgrade it. So any security patches, things like that, it's just a matter of typing yum update, and it'll download any updates to Zen Server, to PHP, to any of the extensions. And there are about 90 extensions that are PHP extensions that are built in to Zen Server. So most of them common PHP extensions that are in use out there, as well as database ones. So obviously we support MySQL database, but Oracle, DB2, Microsoft SQL Server, again on Windows, and the PDO libraries, and I'm probably forgetting one or two, but all of those are kind of built in, plus a bunch more. There's about 90 extensions that are built in there. The support for built-in cache also support cron updates of cache. Not sure why, not sure what you're using cron updates for, unless you're asking if caching works in crons. Maybe that's the question. I don't talk about this much, but the job queue is really where all of that can take place. So a lot of our customers, the downside to cron jobs, and I think your question was, okay, yeah, he said yes. Yeah, can you take advantage of any of the performance things in cron jobs. So no, not directly in a cron job, but you can convert easily a cron job into the job queue. I didn't talk about that a lot today, but you can convert cron jobs into job queues, and you can take advantage of all of the things I showed today in the job queue. So long-running batch jobs, if there's a problem with them, if they failed, you can get a deep analysis of why they failed or why they're running slowly. And if you want to boost that former cron job, if you want to use caching to boost its performance, you can use it. But you basically have to convert it to a job queue. It's very easy to convert it, not hard at all. We have a really good webinar up on our website that talks about job queue specifically. So if you're interested in how you can boost cron jobs, long-running batch jobs, if they're performing poorly, take a look at the webinars on the Zen.com site that are specific to job queuing, and they'll go into a lot more detail. So the answer, long-winded answer is yes, you can convert it very easily to using job queues and then take advantage of all the performance and diagnostics that I just showed that you can use on just plain websites, but you can also use on former cron jobs as well. Okay? Any other questions? I think that's it. Okay. I think that's all of them. Wait a minute. Someone asked, what are the unique PressFlow features? There's no feature difference between PressFlow and Drupal. It all has to do with performance. PressFlow is a performance thread of Drupal. Okay, so that's really it. No functional differences. Okay, and again, you can go on pressflow.org to take a look at the details, source code, all of that. It is open source. Okay, someone else asked, what's the main difference between Zen full-page caching and reverse proxies? I didn't mention this in my presentation, but introspection into sessions, things like that, reverse proxies can't do. Okay, Zen can. Okay, so if you've got scenarios where a user's logged in, okay, and you need to cache, okay, if the session is important, if any of those get parameters are important. Remember I was introspecting caching based on get parameters, based on session parameters. I basically cached anonymous browsing in Drupal, and if you got millions of users on your Drupal site, that's probably the best way of caching. If if you've got a Drupal site that's, let's say, a business site, okay, I have many customers that use Drupal in business. They have 100 users. They've got 50 users using the website, and all logged in, so that it's all authenticated. With Zen Server, you can cache a website with authenticated users as well. Okay, so that's the big difference. Reverse proxies, you can't. You really have a limited set of what is cacheable based on cookies. And that's the reason PressFlow was first created. That cookie kind of flag helps reverse proxy figure out what's cacheable, what's not cacheable. But again, it's not required for Zen Server. Yeah, Zen Server can use it and can definitely cache just like a reverse proxy can, but it also has a lot better introspection. It can take a look at session variables and determine what is cacheable based on session variables, and that's the big difference. And again, very useful in Drupal, also very, very, very useful in custom PHP code, other open source code. And the scenario that I often see in Drupal is again, a business website based on Drupal. They have 100, 200, 300 users using it. They're all authenticated, and there are reports that have to be cached, personalized things that have to be cached based on who the user is, and you can use caching in that scenario. You can use Zen caching based on the session. With millions of authenticated users, you'd have way too much cache data. That's why the scenario in my demo today cached for anonymous usage in Drupal, but business websites that have a reasonable amount of users using it, definitely authenticated caching can also be done, and that's a big difference between the way Zen caches and something like a reverse proxy with its limited kind of caching capability. Somebody asked about the overhead when I was troubleshooting the performance problem in Zen Server. They asked about the overhead. So it's kind of a two-part answer here. So first I wanted to remind everybody about the benchmark that we just reviewed. We basically compared the performance section of Zen Server, okay, compared to other performance technologies, including APC. So apples to apples, Zen Server, bytecode caching, and things like that, we were around 19% faster than APC, okay? So that just gives you a performance kind of threshold. Now, when you take a look at adding the troubleshooting piece, it does require more work. It eats into that extra 19%, somewhere around 5 to 6% into that. So we're still faster even with the troubleshooting piece, even with code tracing turned on 100% of the time. What we see is the triggers themselves help in maintaining performance. And we typically see, again, about a 5 to 6% eating into already the 19% better performance. So you're still going to see better performance out there when you run your applications on Zen Server, even having the code trace on. If you've maxed out your CPU, okay, I have some media companies that are at that have maxed out their servers. We do have a what's called a sleep mode to code trace, where it'll stay asleep, and if a trigger gets kicked off, if one of the event triggers, trouble triggers, get executed and tripped, basically it'll wake up code tracing. It'll basically wake it up for a certain amount of seconds and then put it back to sleep. So if you're kind of at the edge, if you have a website that is definitely utilizing the max amount of your CPU, if you're like a media site and you need that extra 5%, you can turn the code trace into sleep mode, where it wakes up on the first occurrence and it'll capture the second, third, fourth, however long you keep it awake. It'll capture subsequent problems like that one and then go back to sleep. So we do support both kind of capabilities, but our customers are typically keeping this code trace on 100% of the time. Yeah, there's a question here, does the caching work with clean URLs in Drupal and PressFlow? So the answer is yes. We support both the get method and clean URLs, which are very similar to MVC, model programming. Okay, so very, very, very similar. We support both. Okay, so the caching that I showed you earlier would work in both. And that's all of the questions I've had today. So I want to thank you folks. If you have any additional questions, send them to Lydia or myself. I showed you my email up front. It's really easy, edwardk@zen.com. Or feel free to just go on our website, on our forums. They're checked a lot. I do check them. So feel free to go up there, post your questions there. And thank you for joining us today.